All right, next question. We're going to use both forms of the definition of a derivative to find f prime of 1 if f of x equals x squared minus x minus 3. So the first definition that we're going to use to find f prime of a is going to be the limit as h goes to 0 of f of a plus h minus f of a over h. So we're finding f prime of 1. So that's going to be the limit as h goes to 0 of f of 1 plus h minus f of 1 over h. So f of 1 plus h, we're going to take 1 plus h. We'll plug in 1 plus here, and we'll plug in 1 plus h here. So this is going to be 1 plus h squared minus 1 plus h minus 3. And then we need to subtract f of 1. So I'm just going to do that as a side calculation. F of 1 is 1 squared minus 1 minus 3. So 1 minus 1 is 0, minus 3 is negative 3. So we're going to subtract negative 3. Then we just do some simplification. So 1 plus h squared is going to be 1 plus 2h plus h squared. Distribute through that minus, so minus 1 minus h, and then a negative 3 minus a negative 3 is 0. So the 1's will cancel, and then we're going to have 2h minus h, so that'll be h plus h squared. The h's will reduce, so we're going to have 1 plus h. The limit as h goes to 0 of 1 plus h is 1. The second definition of f prime of a is the limit as x goes to a of f of x minus f of a over x minus a. So we're going to plug in for f prime of 1 is going to be the limit as x goes to 1 of f of x minus f of 1 over x minus 1. F of x is still x squared minus x minus 3 minus f of 1, which is negative 3, so we're going to have x squared minus x, and then negative 3 minus negative 3 is 0. So we're going to factor. We factor out an x there on top. So the x minus 1 and the x minus 1 cancel. So we're left with the limit as x goes to 1 of x. We'll plug that in, and we get 1. So we get the same thing from both definitions. We're going to skip this problem. Again, once we have more our actual solutions for derivatives, our actual rules, this becomes very simple. Using the limit definition is quite complicated. So, and you wouldn't be asked to use that to answer this question. So again, it's something that we will be able to do pretty easily soon, but not for right now. So let's look at these multiple choice. At x equals 3, the function is given by this here. So is it, basically we're trying to determine if it's continuous and is it differentiable. So for continuous, we're going to plug 3 in and see if it goes to the same thing. So 3 squared is 9, and 6 times 3 minus 9, 18 minus 9 is 9. So it is continuous. Okay. So it's either continuous and not differentiable or continuous and differentiable. So we want to see if the derivatives at 3 are the same. So I'm going to look at the limit as h goes to 0 of f of 3 plus h minus f of 3 over h. And we're going to do that in both of these equations. So I'm going to start with the x squared. So that's going to be 3 plus h squared minus 9. So that's going to be 9 plus 6h plus h squared minus 9. So the 9's cancel. I'm left with a 6x and an x squared, so that'll be 6 plus h, as h goes to 0, is 6. Now we'll do the same thing with this one. So that's going to be the limit as h goes to 0 of 6 times 3 plus h minus 9. That's the function. And then we're going to subtract f of 3. So we have 18 plus 6x minus 18 over h. All of this is going to boil down. 18 minus 18 is 0. 6h divided by h is just 6. So the limit as h goes to 0 of 6 is 6, which means those are the same. So it is going to be both continuous and differentiable. Final example here. If f is differentiable, then f prime of a is given by which one? So this is absolutely one of our definitions. This is our alternate definition. This one, if you look carefully, if this was h goes to 0, maybe, but it's mixing the x's and the a's and the h's. There's too much there. So it's 1 and 2, which means we're looking at C.